Alright, so in this video, we're going to be doing some practice problems, taking some derivatives of polar equations. Okay, so we have our first problem up on the board here. For the equation r equals 1 over theta, we want to find our derivative dy over dx, right, at theta equals pi. Okay, so first thing we need to do is write down our equation for the derivative. Okay, our equation for the derivative is dr d theta times sine theta plus r cosine theta over dr d theta cosine theta minus r sine theta. Okay, now as I did in the last video, which was the explanation video on derivatives with polar, I like to write out what dr d theta, what sine theta, what r and cosine theta are on the side here, okay, because that ends up, I think, helping, because then you can just plug in and just, simplify and solve, honestly. So first we need to find dr d theta. Now, if r is 1 over theta, then of course we know that dr d theta is going to be negative 1 over theta squared. Okay? And we know that, of course, theta equals pi. So if we plug in that, dr d theta will equal negative 1 over pi squared. So that'll be one thing that we plug in. Next, r equals 1 over theta, which means that we're going to be plugging in, well, when we plug in pi for theta, we'll get that r is equal to 1 over pi. What about our cosine and sine? Well, cosine of pi is going to equal negative 1. And sine of pi will equal 0. So now that we have that, all right, we can just substitute in here, okay? So we know that the dy dx is going to equal, well, dr d theta is negative 1 over pi squared. We have sine theta, that's 0. We have plus r cosine theta, that's going to be just a negative 1 over pi. That's going to be over, well, our dr d theta is going to be negative 1 over pi squared. That's going to be multiplied by negative 1. And then we have minus r, which is 1 over pi. And sine of theta, which will be 0. So this term will go away, this term will go away, and we're left with dy dx equaling negative 1 over pi over 1 over pi squared. Of course, you can flip this fraction up to the top here, and you're going to get the dy dx equals negative pi. Alright, so yeah, I mean, really just finding these four things, plugging them in, and solving. That's really all you got to do. Okay, so that's going to do it for this problem. Alright, so we have our next problem up on the board here. We have the function r equals cosine of 2 theta. We want to find dy dx at theta equals pi over 4. So, we have dr d theta here. What is that going to be? Well, we take a derivative here. We will get 2. Alright, that 2 will come out. And then we'll have sine of 2 theta. And remember, since we're going from cosine to sine, that's going to be negative. So, equals negative 2 sine of 2 theta. Okay? When we plug in pi over 4, we'll get that dr d theta equals negative 2 sine of 2 times pi over 4. That's going to be pi over 2. So, dr d theta will be equal to negative 2. Cool. What about r? Well, r equals cosine of 2 theta, which means that r will equal the cosine of 2 times pi over 4, which will be pi over 2, which is 0. So r will equal 0. What about everything else here? Well, we have a sine and a cosine. So sine of pi over 4 is just rad 2 over 2. And so is cosine of pi over 4. So now we have everything that we need to substitute in, and we can begin that step. So we have dy dx is equal to -2, that's dr d theta, times sine of theta, which is going to be rad 2 over 2, plus r, well, that's going to be 0, times cosine of theta, which is rad 2 over 2, over dr d theta, which will be -2, times cosine theta, which is rad 2 over 2. And then we have just minus r, which is 0, times sine theta, which is rad 2 over 2. This term goes away, this term goes away, and we're left with -2 times rad 2 over 2 over -2 times rad 2 over 2. Of course, that is just going to be 1. So dy dx equals 1. Alright, so, I mean, a little bit of work here. You got to find, of course, 4 different things, and then you have to plug them in, simplify, and find your answer. But really, I mean, it's just algebra stuff, so it's not really anything that you'll have any trouble with. Okay, so that's going to do it for this video.
So if this video helped you, make sure to leave a like and subscribe by clicking my icon in the top left. You can also view the playlist for parametric and polar, the explanation video for derivatives with polar, and the next video in the series. See you soon.